Hi Pre-Calc, welcome back. Today we're going to do an intro on sequences. I've got the checklist on the screen. You know what to do from here. Alright, so a bit of a warm-up. You don't need to write anything down, but if you could please find the limits as x approaches infinity of each of these functions. You can just do it in your head if you would like. Remember, BoboBot needs DC, and then hit continue when you think you've got them all ready to go. All right, so for the first one, you've got exponents are the same, so the limit at infinity should be 3. For this one, you've got bigger on bottom, so the limit at infinity should be 0. And for this one, you've got bigger on top, so there is no limit at infinity, or we can put D and E. If you need a reminder, remember that trig grows the slowest, and by trig I mean sine and cosine, because they really don't grow at all, right? They just bounce back and forth, they're waves. Logs, then they grow, but very, very slowly. Then polynomials, and then exponentials grow the fastest. Go ahead and pause if you need a refresher on any of that, and if you need to write anything down. Alright, so let's do a little intro to sequences. Let's say a virus contaminates an initial population of 1,000 people, and that the virus spreads and the number of people infected doubles each day. So we can write this as a sequence. In other words, on day 1 we had 1,000, on day 2 we had 2,000, day 3 we had 4,000, etc. We can think of sequences really as functions that have a set of positive integers as their domain, like 1, 2, 3, 4, 5, etc. And then these would be our outputs. And the sequence can be either finite or infinite in length. So it could go on forever, or it could have a termination point. So today we're going to look at some definitions and really kind of get into both the terminology and the notation for sequences. So a sequence, and you don't need to write anything yet, but it's an ordered list of numbers. The first number, or also what we call term, is typically denoted by a sub 1. The second term, so the second number in the sequence, is typically denoted by a sub 2, and so on. So in general, if I want the nth term, that would be a sub n. So if I want the fifth term, I denote it as a with the 5 as a subscript, okay? So let's try example 1. It says find the first 4 terms, in other words, the first 4 numbers, and the 20th term of the sequence given by this. I'm going to force a pause on the screen. Go ahead and write that equation. All right, so a sub n is equal to 5 times n minus 3. So if I want the first term, that would be a sub 1. So I'm going to come here to my formula. Anywhere I see an n, I'm replacing it with what? With 1. So I'll have 5 times 1 minus 3, which is 5 minus 3, which is 2, right? Let's find the second term. That would be a sub what? A sub 2. So I'm coming back to my formula. Anywhere I see an n, I'm replacing with what? With 2. So 5 times 2 minus 3, and that'll be 7. Do you see how this is kind of akin to functions where you're plugging something in and looking for your output, right? I'm forced pause on the screen. You find the next 2 terms for me, a sub 3 and a sub 4. Hit continue when you're ready to check your answer. So you should have gotten 12 and 17. If you didn't, go ahead and pause and make any corrections that you need to. Now it also says find the 20th term. What's nice about sequences are written in a sort of general format like this is I just find my 20th term by plugging in 20 in for n, right? I don't have to know the previous terms. So this would be 5 times 20 minus 3, and that'll be 97. First pause on the screen. Before we start looking at recursive definitions, can you go ahead and write sort of just this part that I've boxed here? Hit continue when you're ready to continue. All right, so a sequence may be defined recursively or by using a recursion formula. In other words, it's a sequence that lists the first term or the first few terms and then describes how to find the remaining terms, okay? So before I show you what a recursion formula might look like, let's really kind of get in our heads what all these a subscripts mean, okay? So first term is a sub 1. Second term is a sub 2. Third term is a sub 3. Okay? Dot, dot, dot. Okay, sub 4, a sub 5, blah, blah. Let's say that I'm on a sub n. How would you write the next term? How would you fill in this blank? That would be a sub n plus 1, right? And the term after this would be a sub n plus 2. right? And I can also go backwards. The term before a sub n would be a sub n minus 1. Like if this were a sub 10, this would need to be a sub 9, right? And the term before that would be a sub 8 or a sub n minus 2. All right? Force pause on the screen. Go ahead and copy this recursion formula. Hit continue when you're ready to work it together. All right, so you don't need to write anything else quite yet. Let's just talk about certain terms, okay? So let's say I want to find a sub 3. That means I'm going to plug a 3 in anywhere I see an n, right? So a sub 3 will be a sub 3 minus 1. Well, 3 minus 1 is 2. Then I've got this plus 3. And then times a sub n minus 2. But again, what am I plugging in for n? Plugging in 3. And 3 minus 2 is 1. So a sub 1. So in other words, the third term, a sub 3, equals the second term, correct, a sub 2, plus 3 times the a sub 1, which is the first term, right? Okay, all right, and force pause on the screen. Again, you don't need to write anything, but can you do a sub 4 sort of in your mind? Go ahead and hit continue when you're ready to check. Okay, so in words, we should have gotten that the fourth term equals the third term plus 3 times the second term, right? So what we're doing is to find a term. We're going to take the term before it plus 3 times the term before that one, right? So 2 terms before what we're trying to find. And so that's really a really good way to look at recursive sequences. The temptation is just kind of start plugging in values for n. And that's one way. Things sometimes go awry when doing that. Really try to look holistically at this and think, okay, well, a sub n minus 1 is the term before a sub n. A sub n minus 2 is the term before a sub n minus 1. So what I'm doing is to find the next term, I need to look at the 2 terms before it and use those to find the next term. Force pause on the screen. Can you go ahead and write this equation? Hit continue when you're ready to do this together. All right, so again, if I want to find the fourth term, a sub 4, what would you need to plug in for n here? I need to plug in 3 for all my n's, right? So I'm going to put a 3 here and a 3 here. So a sub 4 will be a sub 3 plus a sub 2, right? Okay, so in other words, the fourth term equals the third term plus the second term, correct? So in general, the nth term, let's say, or if you want, let's follow the formula. So in general, let's write it like this, that the next term in the sequence equals the previous 2 terms added together. Do we agree with that? Because this term is the one right before this one, and this term is the one right before this one. So the next term is the previous 2 terms added together. Okay, now if the first term is 1 and the second term is 1, what would the third term be? 2, right? Because you're adding the previous 2 terms. What would the fourth term be? It would be 1 plus 2, so that would be 3. What would the fifth term be? It would be 2 plus 3, so that would be 5. How about the sixth term? Sixth term would be 3 plus 5, so that would be 8, and so on. This is a special sequence called the Fibonacci sequence. And force pause on the screen, go ahead and copy example 3. All right, so we want to list the first 5 terms of a recursive sequence. So I really want you to kind of zone in on this and think, okay, what am I doing? Well, a sub k, how is that related to a sub k plus 1? We're just using k instead of n here. Yeah, a sub k is the term before a sub k plus 1. So can we again think holistically about this? If I want to find the next term, I take the previous term and subtract 5, right? So a sub 1 that was given, we need a starting point, that's 25. What would the second term be, do you think? would be 20 because I'm taking my previous term and subtracting 5. The next term would be 15. The fourth term would be 10. And the fifth term would be 5. And they're my first 5 terms. Now, we could test this another way and say, all right, like if I want to find the second term, a sub 2, what would I need to make k be for this subscript to be 2? I would need k to be 1, and anywhere I see another k, I would need that. I need to replace all my k's with 1. So a sub 2 would be a sub 1 minus 5. And what was a sub 1? Well, it was 25. So once again, for the second term, I'm getting 25 minus 5, which is 20. So you can do it either way, but again, I really think it's a good idea to think big picture, and it's just kind of think, okay, what is this recursive formula telling me? In this case, it said take your previous term and subtract 5. All right, so last 2 definitions for you. Let's say a sub n is some sequence of real numbers. What we're going to do is consider the limit as n approaches infinity. That's why I had you do that Bobo button warm-up in the beginning. So if your limit is a finite number, let's call it L, then the sequence is said to converge. And we call L the limit of the sequence, okay? Now, if your limit is infinite or non-existent, then the sequence is said to diverge. So the sequence diverges. Okay, so I'm going to give you some examples. Let's say I've got this sequence, 1, and then I take a half of that, which is a half. Then I take half of that, which is a fourth. And then I take a half of that, which is an eighth. And then the 16th. And let's say this goes on forever and ever and ever. Is there a limit? Is this approaching some certain number? Yeah, this is approaching 0. So this is said to converge to 0. Okay. Now, what about if I go the other way? I start with 1 and I double it. So 1, 2, 4, 8, 16, and it goes on forever and ever. Is this going to hit some limit or just explode to infinity? It just goes to infinity, so this sequence is said to diverge. All right? Okay, let's try an example. And first pause on the screen, go ahead and copy the 2 limits. I'm sorry, copy the 2 sequences. Hit continue when you're ready to check the limits. All right, so here, what does this mean? Well, this is a sequence, is what the squiggly brackets mean, if you will. So my first term, if I plug in a 1, will be 3 over 2. If I plug in a 2, will be 6 over 3, which is 2. If I plug in a 3, that'll be 9 over 4. If I plug in a 4, that'll be 12 over 5, etc. Okay? But remember, sequences can really be thought of as functions. So what I'm trying to do is take the limit as n approaches infinity of this. And if we write our first few terms out, sometimes it's not really clear. Are we approaching a certain number or not? Well, we can use what we know about limits at infinity. So what situation do we have here? Bobo, Botany, or EastDC? We have EastDC because you have n and n. So you're going to exponents are the same, divide coefficients. So this is going to converge to 3 over 1, which is 3. And again, this was our EastDC scenario. Okay, let's take a look at this. Do you have bigger on top, bottom, or same? Well, if you take a look at that list we made, the polynomial grows faster than your trig, so bigger on top, and so what does that converge or diverge? That diverges. Okay, so there is no limit because this is bigger on top, which is none, right? Let's try a couple more here. All right, first pause on the screen, you go ahead and write those. Okay, so we've got 1, 1/2, 1/3, 1/4. Can you write this as a sequence, as a formula? Like 1 over n, where n starts at 1. So we'd have 1 over 1, which is 1. Next one will be 1 over 2. Next one will be 1 over 3, because n goes 1, 2, 3. It runs over your positive integers, okay? So taking a look at this, bigger on top, bottom, or same? bigger on bottom because n is degree 1 and 1 is degree 0. So this converges to, what do you think? Converges to 0 because you have bigger on bottom. So bigger on bottom, 0. All right, how about this? 0.3 to the n. Can you write 0.3 as a fraction for me? Yeah, 0.3 is 3 over 10, right? So this is like 3 over 10 all to the n. In other words, 3 to the n and 10 over 10 to the n. So what do we have here? Bigger on top, bottom, or same? Even though they're both exponentials, 10 to the nth grows faster than 3 to the n. So this is actually bigger on bottom, so this also converges to what? This converges to 0 because, again, that 10 to the n, that exponential, beats 3 to the n. All right, you all, that is all I have for today, and I'll see you next time.